Okay, student. Now we are discussing about the some problems based on this topic. So, without actually performing the problems based on revisiting rational numbers and their decimal expansions. Without actually performing the long division, state whether the following rational numbers will have a terminating decimal expansion or non-terminating repeating decimal expansions. Let us take in this recording this we have to take a problem. The first problem based on revisiting 13 by 3125. What we should call, we have to call it as, let us we have to take x is equal to 13 by 3125. Call it as, it can be expressed, rational number means p by q form. Here p is equal to 13, q is equal to 3125. Find out the factor of the denominator. The prime factors of denominator is nothing but q. 3125 are 5 into 5 into 5 into 5, 5 to the power 5. So, if you write this in the form of 2 power n into 5 power m, here 5 power here 5, 2 power here 0. That's why we can write here n is equal to 0, m is equal to 5. And these are non-negative integers. So these are non-negative integers. Hence we can say that x is equal to 13 by 3125 have a terminating decimal expansion. Have you understood, student? See, I will repeat again, once again this problem. Afterwards, again we will do some more problems based on this exercise, based on this topic. What we should call it as, let us we have to take that number as x 13 by 3125, and we can express in the form of p by q, where q does not equal to 0. And we know that here p is 13, q is 3125. What are the prime factors of q? So we should use a prime factorization method. Find prime factors of 3125, like you know that 3125. So find out from that. So like this method you should find out. Then you will get the factors of this number. 5 times 5, that means 5 to the power 5 into 2 power 0, which are of the form 2 power n into 5 power m. That's why here n is equal to 0, m is equal to 5, and they are non-negative integers. Hence it is a terminating decimal expansion. Like that we can solve one more problem. This problem also same thing only. 17, the given number is 17 by 8. Let us call it as x is equal to 17 by 8. Call it as equation number 1. This equation you have to compare with p by q form. If you compare means it is in the form of p by q, where p is equal to 17, q is equal to 8. Prime factors of q are 8 can be expressed as the prime factors 2 cube. So if we express in the form of 2 power n into 5 power m, so m is equal to 0, n is equal to 3. They are non-negative integers. Therefore, x by 80. X by 8, it has a terminating decimal expansion. Once again you can observe, children. So here also the same problem. 64 divided by 455. Then x is equal to 64 by 455. Call it as equation 1. Compare this equation with p by q. P is equal to 64. Q is equal to 455. Here p is equal to 64 and q is equal to 455. As usual, the same method. The factors of 455 are 5 into 7 into 13, which are not of the form 2 power n into 5 power m. Okay. That's why here x is equal to 64 by 455 has a non-terminating, it is not a terminating, it is a non-terminating repeating decimal expansion. Why it is a non-terminating repeating decimal expansion? If it is in the form of 2 power n into 5 power m, then we can say that it is a terminating. But it is not in the form of 2 power n into 5 power m. That's why it has a non-terminating repeating decimal expansion.